Here's our homework, the first homework set, which is a review. All of this is a review. Let's see, this week is a review of beginning algebra, what you would have learned at the very basic stuff you would have learned in beginning algebra, and then moving on with what you learned in intermediate algebra. Okay, and then we'll be on and off reviewing intermediate algebra all semester long as it becomes applicable to college algebra. All right. So we're going to talk about functions. They're probably the most important topic in mathematics today, and actually for the last 100 years. Here we're being asked about a series of graphs, and this is the way you first learned about functions. We're being asked, is this the graph of a function? 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 And it's just a yes or no question. And I already have the answers here, so you can see the answer is yes for this, but I need to tell you why, because you won't have the answers when you do your homework. There, that's good. Okay, I want the color to be red though, yeah. The quick and easy, the dirty way to figure out if a graph is the graph of a function is to use the vertical line test. Remember that, and you draw or you imagine drawing a vertical line through the graph. Usually at a couple of different points. So like here, and here, you don't have to be careful. And here. It's just good to have it at more than one point. All right, here's what the vertical line test teaches you. So I'm going to write vertical line test. Use vertical line test. If this line crosses the graph and touches the graph at only one point, everywhere on the graph, then what you've got is a function. And notice that no matter where I draw a vertical line here, that vertical line will touch the graph at only one point. Heck, it's a function. Yay! Now, we have a different deal going on with this graph. I've drawn relatively vertical lines through the graph, and notice that my vertical lines touch the graph at 2 points. Not one, but two. Now, on the other hand, if I had drawn a line through this point, it would say, well, you only intersected the graph at one point, which is why I need multiple points, or at least I need to imagine that I'm drawing vertical lines through more than one point. Because even though if I draw a line here, or if I draw a line here, the vertical line will go through the graph at only one point. Here goes through two. So the answer is no here, because the vertical line intersects the graph at more than one point. Let's write that down. For people who have come in a little later, we are reviewing. I know that you all already know this, but review is good. The vertical line intersects the graph at more than one point. Okay, here we have a vertical line that does the same thing. If I had drawn the vertical line here, of course, it would intersect the graph at only one point, but over here and at other places on the graph intersects, the vertical line intersects the graph at more than one point. So no, again, the vertical line, the VL, intersects graph at more than one point. Okay, but why? I mean, in math, we don't usually go around just showing pictures. I'll tell you in a minute. Let's do this. Okay, this looks for all the world like it could never be a graph, but if you draw a few of these vertical lines or semi-vertical lines through the graph, you'll see that, well, these vertical lines are indeed intersecting the graph at only one point. So even though this looks incredibly complicated, like it could never be a function, it is a function. It passes the vertical line test. That is, a vertical line intersects the graph at only one point. Intersects graph at only one point. There. All right, so let's talk about why. Why? Let's get technical for a minute. Let's look at this vertical line right here. Right here. Let's see, this point, the point of intersection, is the point. Let's see, you go one to the right, and 1, 2, 3, 4, 5, 6 up. So this is the point 1, 6. And it matches up with 1 on the x-axis and 6 on the y-axis. In mathematics, we talk about mapping. What functions do is they map. Functions map x coordinates to y coordinates. This particular PDF editor is hard to write on. The one that I'll use for the next homework set is neater, much easier to read. Okay, so over here, the number 1 on the x-axis is being mapped to the number 6. Let me make this much bigger. One is being mapped to 6. And where the mapping occurs is right here at this point, 1, 6. Okay, over here, 1, 2, -1, -2, -3, -4, -5. This is -6 on the x-axis. 1, 2, 3. This is 3 on the y-axis. So this point, see, look at that 6. That is a sick 6. Oh, good. All right. Let's try that again. 6. Okay. That makes this point -6, 3. Which means the number -6 is being mapped to 3 at that point right there. And it's the function, the graph, that's doing it. There's no confusion. -6 is definitely being mapped to 3. +1 is definitely being mapped to 6. I know exactly where number 1 goes. I know exactly where -6 goes. Now, and that makes a function. Come over here. Here's 1, 2. Here's 2 on the x-axis, right here. 2 is being mapped to whatever that y coordinate is up here. Let's say it's 1, 2, 3.8. Let's call it 3.8, okay? So 2 is being mapped to 3.8. I just made that up, of course. Need more room. But 2 is also being mapped to whatever that number is. -1, -2, -3, it kind of looks like -3.5. So 2 is being mapped to -3.5, which is 3.5. Now tell me, where is 2 going? Is it going to 3.8 or is it going to -3.5? Where can I find it quickly? That's why this is not a function, because there's confusion about what is happening, where 2 is being mapped. Is it going to New York City or to California? Well, there is absolutely no confusion here. 1 is being mapped to 6, no problem. Down here, I don't know which one to say 2 is being mapped to. It's being mapped to 2 different y coordinates at the same time. So it's not a function. That's why, if you were interested.